Yeah. So good day to all the students. I am Dr. S.S. Rao, Professor in Department of Mechanical Engineering, Koneri Lakshmiya Engineering College, Guntur, and my subject is control of mechatronic systems. So the control of mechatronic systems subject we are going to handle. So in this session, the outcome is end of the session you are in a position to understand what is the control systems, what is the control systems. And in this session we are planning these contents, that is the introduction to control systems and key mechatronics elements and control system design process, human system and control system components. So in this session I want to cover all these elements. This will give the brief introduction about the control systems and what are the basic mechatronics elements are included in this control system. I will want to explain, and the system design process, what are the stepwise design process of the control system I want to explain, and how the human system is replica of this control system want to explain, and the control system main components want to explain. Now coming to the control of mechatronic systems. So a control system is a device or a set of devices that manages, commands, directs or regulate the behavior of other devices, other systems. So industrial control systems are used to for industrial production, for controlling the equipment or machinery. So what are the main disciplinary are included in this system? That is a synergetic of the following disciplines. One is the mechanical engineering, electrical engineering, electronics engineering, computer science and the information and technology engineering. All together are combining to develop the system. That system is known as a mechatronic system. The name itself is their mechatronic system, the mechanical, electrical and computer science. So, okay. So, this information technology also subcategory of the computer science. So, main is a mechanical system, electrical system and the computer system. The electronics also inbuilt with the electrical systems. So, this combined together to achieve the desired outputs by giving the inputs. So, a control system consisting of interconnected components designed to achieve the desired purpose. Our aim is to get the desired purpose. These are the different components are interconnected, that is the mechanical components, electrical, electronics and the information passes through set of programs. You are require the computer knowledge and also the information technology to transfer the information from one system to the other system, one device to the other systems. It is a interconnected components is designed to achieve the desired purpose. To understand the purpose of control system, it is useful to examine examples of control system through the course of history. So, in this course of history, the different the practical examples are we consider and we are explaining the how it will be the involving all the disciplinary for getting the desired output. So, these early systems incorporated many of the same ideas of feedback that are used in today's. So, modern control engineering practice. In the modern control engineering practice includes the use of control design strategies for improving manufacturing processes, the efficiency of energy use, advanced automobile control including the rapid transit among others, and basic mathematical tools such as the Laplace transformations and transfer functions, block diagram, signal flow graph, mathematical modeling of dynamic systems, time response analysis, stability of linear systems and root locus and frequency domain analysis are utilized. The control systems mainly this the knowledge of these the areas, that is one is the mathematics, that is the Laplace transformations and transfer function, block diagram. We have to explain the different the transfer of the different signals through the block diagrams and signal flow graphs. The signal flow graphs is very important in the analysis of the frequency domain, how the signal is transmitted from one unit to the other unit, you can easy to explain through the signal flow graph, and mathematical modeling of dynamic systems. So, you have to develop the mathematical model equations, and you have to study the behavior of the different mechanical systems, and with the giving the input of the different control parameters, and the response analysis, and here you have to do the time analysis and also the frequency analysis we are going to discuss in this course of study. Now, coming to the basic elements in the control system, the system in interconnection of elements and devices for a desired purpose. What is, you can call it as a system. You can take any system that should be the interconnection of the different elements and devices for a desired purpose. The purpose is a desired focus purpose we are going to achieve by interconnecting the elements, that is forming as a system. And what do you mean by control system? So, an interconnection of different components forming a system already discussed. Okay. That configuration that will be provide a desired response by controlling the different parameters. For controlling the different parameters in that elements to achieve the desired output, that system is known as a control system. See simple example. The simple example is if you take the ceiling fan. Okay. So, the ceiling fan is having this hub and 3 wings or 4 wings. Okay. And if you see that the hub is rotating, and once wings are fixed, along the wings if rotating, what happens, the airflow will come. If there is no wings, only that hub is there, hub is still rotating, but there is no airflow. That is, our desired purpose is to get the air, but air is not coming. Why? Because these wings are not there, the wings are absent. Okay. And so that is because it is rotating, it is forming as a system, but once we call it as a control system, once you have all these elements and you have to control the different speeds, different airflow, we are applying this with the help of the regulator, and that system is called it as a control system. If there is no regulator, once if you directly connected to that fan to the directly the switch, if you switch on, the fan is rotating with a desired that speed. But our desired speed is varying from the different atmosphere conditions. Okay. For winter we require the less amount of airflow, and for summer we require the more amount of airflow. So, in that case we require the regulator. Here regulator acting as a control. So, that system we are incorporated the regulator, that system is called it as a control system. Like that, if we take any systems and controlling those parameters, I will call it as a control system. Process. The device, plant or system under control, the input and output relationship represents the cause and effect relationship of the process. Cause and effect, if you see the help of this diagram, you are giving the some inputs, you are giving the some inputs to the process or system. This is entire, you can call it as a system. So, in the system we are giving the inputs and we are obtaining the desired output. This is a simple the flow diagram of the control system. So, that for system you are giving the inputs, the process is carried out and you are getting the desired output. So, a system can be defined as an arrangement of parts within boundary which work together to provide a desired output from the specific inputs as shown in the figure. See in the next slide that the different system is bounded with the flow boundary, and how the inputs are influencing and how the outputs are obtained we will discuss in the next slide. The boundary separates the system from the environment, and the system interacts with the environment by means of input and output signals. So, this one particular boundary you can separate this system from the environment. This entire thing is called it as environment. In the environment you have to separate our system with the help of laying some boundary, and within the boundary there is a several systems may be there, the interconnector systems may be there, and the inputs and output the signals will be interacting through this boundary to the environment. So, input signals may be some sort of disturbances to the system along with the desired input signals. Now, we will see that how that system, the environment is separated with the system. Now, just I plan this system is like this. Okay. Now, this system is having the different subsystems. Let us, if we take, this is the subsystem 1, subsystem 2 and subsystem 3, the entire is called as the systems. Again, inside there is subsystems are there, and the control inputs, the desired inputs, we are giving the desired inputs and we are expecting the desired outputs. Along these desired inputs, there is some disturbances also acting on the system, on the boundary. The disturbances inputs also acting on the boundary. Now, we are designing the control system in a such a way that it will take the desired inputs only. The disturbances output inputs are, it will be not allowing to the system, and there is a separate design, those are obstacle these disturbances, or it will suppress these disturbances, and it is not allowing to interact with the systems. Only the interact with systems is the desired inputs, and you are getting the desired output. Okay. So, that is the control system depicting the various inputs and outputs. So, entire the control system, it having the inner, there is a several n number of inputs may be there, okay, and there is n number of disturbances also acting on the system, but even though it will get the desired output, then only you can call it as this is a control system. So, now what are the key elements? In the mechatronics, there is a key elements are there. With the help of these key elements, we are going to analyze the performance of this system. What are the key elements? The basic 5 are the key elements.